All right, so we're going to look at putting it all together. So 0 is a polynomial function. 0 is an x-intercept. If it's imaginary, though, remember that it will not be an x-intercept. So we should say real zeros are an x-intercept, but that is always a good starting point for us. So our first example actually says to factor, but we skipped our little factoring section. So if you know how to factor, go right ahead. I'm going to suggest instead that we graph the function. I think most of us would prefer to graph anyway because Desmos makes it real easy. And I want to know, where does it cross the x-intercept? Where does it cross the x-axis? That's called an x-intercept. And that is at -3 and 3. Okay? So, -3 and 3. Here, we'll make our graph somewhat accurate since it's pretty easy to. Dang, that's way down there. At -81. This is usually a little flatter because it's to the 4th power. Okay, but we really care about the -3 and 3. So what we're going to do is rewrite this so that it's x to the 4th plus 0x cubed plus 0x squared plus 0x minus 81. Because I am going to divide that by one of the x-intercepts. It doesn't matter which one, but I'm going to divide by that. And then my numbers are 1, 0, 0, 0, -81. So it's very important that you have already watched 3-4 video, because if you have not watched 3-4, then this one, you have no idea what that box I just made is. Okay? All right. We're going to bring down the 1 all the way to the bottom. 1 times -3 is -3. Add straight down. Repeat. -3 times -3 is +9. Add straight down. Repeat. 9 times -3 is -27. Add straight down. -27 times -3 is +81. Add straight down is 0. I should get a remainder of 0. If you notice, I put a little note over here in the blue box. An x-intercept will give us a remainder of 0. So if you don't get a remainder of 0, you've probably done something wrong. Okay? All right. So here's what's nice. I'm going to divide by all the real zeros that I can, meaning all the x-intercepts. So my next x-intercept is 3. This is why order didn't matter, because you might have got something different if you did 3, but then when you divide by -3, you're going to end up with the same answer. Okay? Bring your 1 all the way down. 1 times 3 is 3. Add to get 0. 0 times 3 is 0. Add to get 9. 9 times 3 is 27. Add to get 0. So again, I got a remainder of 0. Check, check. Okay. So what that does, so this was, original was 4th power. The first time I divided, it made it the 3rd power. That means that this one is squared. So this was x cubed. This one has to be x squared. So I have 1x squared plus 9 equals 0. If I wanted to find the other zeros, I would solve for x. So x squared equals -9 square root. X equals positive or negative, because I took the square root. The square root of 9 is 3. And anytime I have a negative under the square root, it's imaginary, so it's I. So positive or negative 3i. Here are the connections I want you to make. So we have kind of taken this problem a little further than what they had originally anticipated. But there's a lot of connections here. This is to the 4th power. That means that it should have 4 zeros. I'm actually going to change that color there. I don't know what color I want today. All right. 4 zeros because it's to the 4th power. But notice it only gave me 2 of them on the graph. That's because there's 2 real zeros. So all the zeros are negative 3, 3, positive 3i, and negative 3i. So all 4 because it was x to the 4th. Okay? And I knew that 2 of them were going to be imaginary because if 2 were real, meaning they were on the x-axis, 2 plus 2 is 4. All right. Describing behavior. If something is raised to the odd power, it will cross the x-axis. We're going to look at what that means. If something is raised to the even power, it touches the x-axis and goes back. So, here's my picture. This is what I mean by touches. Because then it touches it, but then it goes back down. That happens at an even power. Crosses means it was under and goes over, or it was over and goes under. Okay? So, I know by looking here, this x is to the 1st power. This x plus 4 is to the 1st power. X minus 1 is to the 4th power. So, crosses, because it's odd, crosses, touch. Now, what are my zeros? Well, if it's written in factored form like this, it's really easy to do without a calculator. You just set each one of those equal to 0. Hopefully you notice that those are really easy problems, like this one's done. So x equals 0. This one is x equals negative 4. And this one is x equals 1. Okay? So when we describe the behavior at the zeros, we say that it crosses at 0, crosses at negative 4, and touches at 1. So let's look at that on Desmos. So x times x plus 4 times x, I've already forgotten, I apologize for the back and forth here, minus 1 to the 4th. Okay, let's readjust here. It crosses, so it was above and then goes below at negative 4. It touches at 0, so it was below and then it goes up, although it doesn't go up very far because then it immediately comes back down to 1, but bounces back off of it. So sometimes people use the word bounce. So like a ball, it's going to hit it and then bounce back. That happens at an even power. Okay. All right. This one is tricky. They trick you because this part right here is imaginary, so it doesn't even show up. So you only have to answer about those zeros. If you ever have, I'm going to keep on moving for time's sake, but if you ever have any questions over like the crosses versus touches, graph it. Put it in Desmos, graph it, and then it can show you whether it crosses or touches. Okay? All right. What are all the real and complex zeros of the polynomial function? Well, if I look here, it came with a graph that is at negative 2 and 2. So x to the 4th is missing the x cubed component, so 0x cubed, and that should be minus 3x squared. It's missing an x, like the 0x term, minus 4. So we're going to do 1, 0, negative 3, 0, negative 4. Pick my number. I'm going to do negative 2 first. Okay? Bring it down. Multiply. 0 minus 2 is negative 2. Multiply to get positive 4. So negative 2 times negative 2 is positive 4. Add to get 1. Repeat. Negative 2. Add down to get negative 2. Multiply to get 4. Now I have 0. Now I'm going to divide by the next one, which was 2. Bring down to get 1. Bring down to get 0. 0, 1, 2 for a remainder of 0. So notice this was very similar to that first one, okay? So my real zeros are 2 and negative 2. My imaginary zeros are, remember this was x cubed answer, so this one has to be x squared because it keeps going down 1. This was to the 4th, to the 3rd, and then squared. So I have 1x squared plus 0x plus 1, which is just x squared plus 1. Set that equal to 0. X squared equals negative 1. Take the square root. I get plus or minus because I took the square root. The square root of 1 is 1. And then the negative means that it's I. So my imaginaries are I and negative I. Notice I have 4 zeros total because it is to the 4th power. Backing up to these, this is called multiplicity, so that would be a multiplicity of 4, so it would count 4 times towards the total number. All right. Last but not least, if we want to solve polynomial equations, we could set it equal to 0, find the zeros, so forth and so on. Desmos is very intuitive, so what I would do instead is the trick that we have worked on in each unit, where I put the left side on one line and the right side on the other line in Desmos and state where they cross. So for that first example, it was x cubed minus 7x plus 6. The second one was x cubed plus 5x squared minus 2x minus 24. Hey Google, stop. That's my alarm for class, so good thing I'm almost finished. We are going to spot all the places where the purple and the black cross. And that looks like it. And those are our answers. So 2 and negative 3. Remember, we do not need the y values because there's only an x there. So I put this side in one line and this side in the other and state where they intersect. All right, that's the last of your notes and you are finished. So now time to try your target.